Hello everyone, I am Dr. Lalitha, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. In today's video, I am going to explain about the important topics KVL and KCL. Kirchhoff's current law. So first, we'll start our video with Kirchhoff's current law. So what is Kirchhoff's current law? Kirchhoff's current law is having another two names, which are called as Kirchhoff's first law and Kirchhoff's junction rule. So junction. So what is meant by junction? Joining of two or more points is called a junction. So junction is also called a node. So here I am considering a junction or a node. Okay, means so many number of branches will join here. So let us consider I amount of current is flowing into this junction. Into means towards the junction. So from this junction there will be so many connection of branches. So let us consider here I1 amount of current is flowing outside the node, I2 amount of current is flowing, I3 amount of current is flowing in this branch outside the node. So according to the KCL, the total current I is equals to I1 plus I2 plus I3. I1 plus I2 plus I3 means the total current which is entering into this node is equal to the sum of total currents which is going outside the nodes. So according to the junction rule, the total currents in a junction is equals to, the total current will be equals to the sum of the currents outside the junction in a circuit. So this is KCL. So next coming to KVL. So KVL is also having two names which are called as KVL means Kirchhoff's second law, or we'll call it as Kirchhoff's loop rule. Loop. What is meant by loop? A closed path. A closed path. Inside a closed path, we'll draw a loop. So according to this KVL, so algebraic sum of voltages in a closed loop is equals to 0. So let us consider here a small circuit. Okay, with voltage V, R1 resistance, R2 resistance. I amount of current is flowing inside the circuit. So here positive direction is this side, so that's why the flow of current is this side. So I am considering the loop, okay, according to the direction of current which is flowing in the circuit. So according to the KVL, algebraic sum of voltages. So here where are the voltages means? Near the resistors, there will be some amount of voltage drop according to the property of resistor. So what is the property of the resistor? It will oppose the flow of electrons into it. So because of this opposition, there will be some loss of energy. So that loss of energy will be in the form of heat. So there will be some amount of voltage drop. So that amount of voltage drop according to means here at resistance R1 we will consider as V1, at resistance R2 we will consider as V2. Why I am changing V1, V2 not constant means, so for each resistor the value of voltage drop will get varied. So it won't be same for all the amount of resistors. So for R1 I am defining as V1, for R2 I am defining as V2. So algebraic sum of voltages. Here in this loop what are the voltages in the circuit? So here V1 is there. So I am starting from the direction of the current. Okay. So after considering, so V1 is there. So V1 plus, so from V1 it is flowing here plus V2. So the same loop if we close here, if we see it very clearly, so here there is a negative sign. So here the value will be minus V. So the signs are very much important here. So if you keep or if you misunderstand here in this loop means the entire problem will get wrong. So you have to look carefully here. So V1 plus V2 minus V is equals to 0. V1 plus V2 minus V is equals to 0. So V1 plus V2 is equals to V. V1 plus V2 is equals to V. So this is KVL, Kirchhoff's voltage law. So algebraic sum of voltages in a closed loop is equals to 0, which is nothing but the Kirchhoff's voltage law. What is Kirchhoff's current law? At a particular junction or a node, the sum of the currents entering into the node is equals to sum of the currents leaving the node. So now let us see in detail about the Kirchhoff's laws. So first, according to the KCL. So what is the KCL? If we see in this particular example, this is a junction or a node. Okay, this is a junction or a node. So according to the KCL, the total current entering into a junction, okay, some of the currents are entering here, entering into a junction or a node is equal to the charge leaving the node as no charge is lost. Means see here, this is a junction. See here, the same diagram I am showing here. So here there are different paths of flowing the current. Okay, so here I1 is flowing towards the node. Okay, towards the node. Here I2 is also flowing towards the node. I3 is also flowing towards the node. Means I1, I2, I3 are towards the node. These three are towards the node. Okay, if we see I4 and I5, so the directions are outside. See here. See, the directions are like this. Means I4, I5 directions are opposite to that of the directions of I1, I2 and I3. So here, what will be the equation according to the KCL? So sum of the currents entering into the node means I1 plus I2 plus I3 is equals to sum of the currents leaving the node. So leaving the node, what are the currents leaving the node? I4 and I5 is equals to I4 plus I5. So according to the KCL, this will be the equation. So in this problem or in this circuit, so I1 plus I2 plus I3 is equals to I4 plus I5. And another important thing was the algebraic sum of every current entering and leaving the node has to be null, means 0. The property of Kirchhoff's law is also called as conservation of charge. So how much amount of current is exiting plus how much amount of current is entering, both should be equals to 0. How much amount of the current is entering plus how much amount of current is getting exit. Both should be, if we add both, it should be get equals to 0. So I1 plus I2 plus I3, I am taking this side, plus I4 plus minus I5 is equals to 0. Is equals to 0. So this will be the equation for KCL. This will be the equation for KCL. So the same I had represented here. So in the above figure, the currents I1, I2 and I3 are considered as positive and the remaining I4 and I5 are negative. So for the positive ones, I had written as positive. Positive ones means entering the node. So these three are entering. So I1, I2 and I3 are entering. So I1 and I2 and I3 both I had added. These three I had added, minus I4 minus I5 is equals to 0. So as I told you before, what is a node? A node refers to a junction which are connecting two or more current carrying routes. Okay, it should provide a path for the flow of current. It may be a conductor or it may be a cable or any other components, but flow of current should be taken place. So Kirchhoff's current law can also be applied to analyze the parallel circuits. So now we will go to the Kirchhoff's second law or Kirchhoff's voltage law. So what is Kirchhoff's voltage law? So I had told you what is Kirchhoff's voltage law? Algebraic sum of voltages in a closed loop is equals to 0. See here, I had considered a circuit, a small circuit here. So A, B, C and D. So between A and B, one resistor is there, B and C, one resistor is there, C and D, one resistor is there and D and A, one resistor is there. So for every resistor, there will be some amount of voltage drop in the circuit. So the value of voltage drop of this resistor will be equals to VAB. Here VBC. So here VDC or VCD, whatever it may be. So next here VAD or VDA. So if I had considered the value from here, so VAB plus VBC plus VCD plus VDA should be equals to 0 according to the KVL. So algebraic sum of voltages, the voltage around the closed loop or around a loop equals to sum of every voltage drop in the same loop for any closed network is equals to 0. In this closed loop, algebraic sum of voltages, only these values of voltages are there. So we are adding all these voltages and are making it equals to 0. So put differently, the algebraic sum of every voltage in a loop has to be equal to 0 and this property of Kirchhoff's law is called conservation of energy. So how we can define it? Voltage drop means VAB plus VBC plus VCD plus VDA. All should be equals to 0. The sum of all voltage drops around the closed loop is equals to 0. Okay, this is KVL. So now let us see a problem based upon this KVL. So here this is the circuit. So in this circuit they had given R1 as 2 ohms, next R2 as 4 ohms, R3 as 6 ohms. So these two are batteries. So see here very carefully, batteries can be represented either by E1 or V1. Both represents battery only. So E means EMF. What is EMF? What is voltage? So voltage means, voltage is nothing but a force which tends to produce current in the circuit. Then what is EMF? EMF is also a force which tends to produce current in the circuit. Then what is the difference in between the voltage and EMF? See, voltage is nothing but the electrical terminology. Okay. So if suppose supply is there, so voltage will be there. So based upon that, the current will flow in the circuit. So if suppose, for example, power supply is not there, so then what we will say? Turn on the generator. Okay, or we will say like that. So if we turn on the generator, what will happen? Finally, what should be done? Our load should be operated properly. Means our fans, lights, whatever it may be, it should be operated normally as like before. So how it will operate? For operating, definitely we need a current, right? But here there is an absence of electrical energy. So in the absence of electrical energy, in the presence of voltage, there should be some other force which should do the function same as like the voltage. Means voltage is not there, but the thing is that something has to do the work of the voltage and make the current to flow in the circuit. That work will be done by EMF. EMF is also nothing but a force which tends to produce the current in the circuit, but in the absence of electrical energy, means in the absence of voltage, we will use the EMF in order to produce the flow of current in the circuit. So in some cases, we will represent it as E1, or EMF is represented by E and its unit is also volts. So in some circuits or in some problems, it may be voltage source may be defined as V, or in some problems voltage source may be defined as E. Don't get confused, because the ultimate thing is that the flow of current should be there in the circuit. Whether we had given by EMF or whether we have given by voltage, that is secondary, but the force should be come in order to flow the current in the circuit. So for that case, here in some problems they will represent as E1 and in some problems they will represent as V1. Okay, don't get confused. So first they had given the problem like this. So if they had given the problem like this, the first thing what we have to do is we have to choose the direction of the current. So based on the direction of the current only, we will draw the loops and we will apply the KVL in the circuit. So generally we will consider the clockwise direction. Clockwise direction we will consider, because whenever there will be current flow in the resistor, there will be a potential decrease. Means there will be some amount of voltage drop in the circuit, obviously. So that value will be given by V is equals to I into R. So across each resistor, there will be some amount of voltage drop, and that amount of voltage drop will be calculated by V is equals to I into R. Next, if the current flows from the low value to the high value, so the EMF, means here I had considered the EMF, means E, or otherwise the voltage source will be signed positively, because it is getting charged from the EMF source. So likewise, if the current moves from the high to the low voltage, means high voltage to low voltage means positive to negative. So then the source EMF is signed as negative because of emptying the energy of the EMF source. So in this solution or in this problem, the direction of current is same as the direction of the clockwise direction. So now let us solve this problem. So now let us solve the problem here. So what are the values which they had given here? 2 ohms, 4 ohms and 6 ohms. So 2 ohms, 4 ohms and 6 ohms. These are the values which they had given. So now if we see here, see the direction of current, considering the direction of current plays a major role here. See from the battery here the negative value is there. See, okay, this negative value will go like this. So here the negative value will be there. Here also negative value will be there, negative value will be there, and the loop will continue here till here. So what is KVL? Algebraic sum of voltages in a closed loop. In a closed loop means, see, from here I had started. So it have to complete all these loop and we should end here only. Okay, from where we had started, we have to end there only. So I had started from here. Okay, consideration of sign plays a major role here. If we consider a wrong sign, then everything will get wrong. So we have to take care of the sign. So from here I had started, I am moving like this towards the closed loop, and here it is getting ended. So here negative value is there. So the negative value is going like this. So here across every resistor, what will be there? There will be some amount of voltage drop in the circuit. So across R1, V1 will be there, across R2, V2 will be there, across R3, V3 will be there. Okay, so why will be there? There will be a voltage drop across each resistor. So while the current is flowing into the circuit, what will happen? What is the property of the resistor? It will oppose the flow of electrons, so that some amount of energy will be lost. So amount of energy will be lost in the form of heat, and there will be some amount of voltage drop. Okay, so that voltage drop here V1. So V1 means V is equals to, as it is a series circuit, the current flowing throughout the circuit will be same. Actually V1 means I1 R1, V2 means I2 R2, V3 means I3 R3, as we all know according to the Ohm's law. But in the series circuit, so the total current flowing into the circuit will be same. So I1 is equals to I2 is equals to I3 is equals to I. Okay, so according to this we have to write down the equation carefully. So here see, minus V1 is coming. So V1 means I1 R1 actually, but I1 is equals to I. So I into R1 minus I into R1. Okay, next it is coming here. So minus into minus, what it will become? It will become plus. So plus E1. So again it is coming like this. The value is minus. The same here. So minus IR2. It is closing here. It is entering this side. So minus IR3. Here actually positive sign will be there because this is the symbol of battery. Okay, positive and negative. But here, as I am considering the symbols also, here positive sign will be there. Here the negative sign, from the negative sign we have considered. Okay, so here if we are turning like this, here positive value is there and negative value is coming. So minus into plus means minus. So minus E2 is equals to 0. So now substitute all the values here. So what is the value of I is the unknown value here. Okay, here I is the unknown value. So what are the values which we know here? R1 values we know. Next E1, E2 values also we know. So substitute the values here. So R1, what is the value of R1 here? 2. So minus 2I1 plus E1 means 10. So plus 10 minus I1 into R2. I means I into, what is the value of R2? 4. So minus 4I. Next minus IR3. So minus I into R3 means, what is the value of R3 here? 6. So minus 6I minus 5 is equals to 0. So if we solve this, we will get I is equals to 0.416. So we can able to find out the value of the current by using this KVL. So the electric current flowing in the circuit will be equals to 0.416 amps. So the total electric current is here, it is signed positive. That means the direction of electrical current is same as the direction of the current direction which I had considered. What I had considered? Clockwise direction. So the direction of the electric current is same as the direction of the clockwise direction. So if the electric current is negative, then we can treat it as the current would be in the anti-clockwise direction. So based upon the symbol which we got, whether we got positive or negative, we can determine the direction of the current, whether it is flowing clockwise or anti-clockwise. So here I had considered here it is as negative. So for example, we will see a small example how we can consider the same equation, means a small circuit with positive. So here positive, negative, V, battery V is there. So here let us suppose 3 ohms, 2 ohms. Okay. So here it is there like this. So here from negative sign we have considered, but here in this case we have to consider positive sign only, because see here what is the first we got here plus. So the current is flowing like this. So the current will be positive because here positive charge is there. So in this case, how we'll write down the equation? So total current I is flowing in the circuit. So according to the KVL, algebraic sum of voltages in a closed loop is equals to 0. What are the amount of voltages? 3. This is R1, no? R1, R2. Right? So 3 into I1 plus 2 into I1. If it comes near to here, okay, comes near to here. So here negative sign is there. So we have to consider negative sign. Here how we had considered, from negative side we have considered. So if it comes like this, here it came positive. So minus into plus became positive, into negative became negative only. But here from positive we are considering, the throughout it is flowing positive. Again here from positive into negative became negative here. This is such case. So let us consider the voltage is 2 volts. So minus 2 is equals to 0. Okay. So likewise we are going to write down the equation for KVL. Okay.